Hello everyone, and welcome to API Days Connect, HongKong 2023. For this next session, we're going to talk about the Zero Trust architecture from an API developer's perspective. My name is Dipin Behl. I've got 17 years of professional experience in designing different digital solutions for a lot of industries, a lot of domains. Currently, I'm a principal engineer with Striker, based out of the Striker Global Technology Center here in India. I like to begin with my favorite quote: make everything as simple as possible, but not simpler. But this has actually helped me put out great products in the market and has become the de facto principle when I design anything. So today, we're going to talk about the zero trust architecture, and we're going to start with asking ourselves a very simple question: what it is. And we're going to see what the fuss is all about. From then, we're going to move on to why do we actually need that? And then we're going to try to answer that how do we get that zero trust infrastructure into our API system? And finally, we want to end with, oh, now I know I'm an advisor about zero trust architecture. So driving straight into it, this post-COVID, we've gone a lot much remote. We have got gone very distributed. The new normal has taught us that working from remote locations, from outside the enterprise network, using our own devices, that is becoming the new norm. So that's where I believe that zero trust architecture adds a lot of value to any enterprise network, and it adds a lot of value to our API ecosystem as well. Now, this concept of zero trust architecture, it's not something new that has just evolved. In fact, it was proposed quite a while ago by the US Department of Defense. It was basically a thought that we move away from that parameter-based security where everything depends upon networks. We move away from that and into a world where everything else is identified as a resource. And that's why they say the basic principle of zero trust architecture is never trust, always verify. No, you see the basic four quadrants around zero trust architecture. These are the participants in an architecture, and these are the things that we want to protect. These are the ones that we're going to verify. So infrastructurally, we need to verify if a request comes in from a valid infrastructure, from a valid network, from a valid server. You're gonna see that it has the proper rights to accessible data. It comes from a registered application, and it actually comes from a device that is allowed to access the data using an identity. So all of these form the basics of zero trust architecture, and we as the API developers are bound to use almost every part of this infrastructure. So that's why bring them this value. If you're enterprise, if you're application, if you're holistically you're going to that zero trust architecture, you as API developers need to be part of it because every part of this quadrant belongs to you. The basic principles of a zero trust security is to verify explicitly, which basically means that we need to validate every aspect of a request processing data. Where it originated from, did it come from a valid device? Does it come from a valid network? Does it have the correct identities? And once that has been verified, go to our least privilege access principle, which basically means that you only have rights to do certain amount of job. That's it. The necessary rights only. And everything beyond that needs to be requested, needs to be approved. And the third and the very important principle about zero trust security is we assume breach at every moment. So this basically means that we are thinking that every other component within the network, every other neighbor that we have to our microservice, that has been breached, and we must protect our microservice from all those blast radius. So it's all about minimizing that blast radius in case of a breach, and we are assuming that has already been done. Now, about uh, uh, some best practices in zero trust security is that we believe that everything behind the corporate firewall is not safe, and then we micro segment on our all our infrastructure. And now in an API ecosystem, we've been creating microservices for quite a while now, and all those microservices can be microsegmented. And then we drive policies on how communication happens between them. And later we're going to learn how we establish trust with them. And this is all about minimizing that lateral movement in case of a breach. And once that has been done, another best practice is getting those ACIM and so on tools so that you can use AI to monitor them, you know, basically respond to them as quickly as possible. And finally, one of the best practices is using MFA, which almost every enterprise is doing these days. Now, the very first thing I want to talk about is why do we need it? We already had perimeter security, and that was working fine for us. So why do we need this now? Now imagine we traditionally had our applications dematerialized into a specific zone, into a network. Now, if you think about it, let's say somebody breaches that perimeter and gets into one of the areas. Now he's free to roam around in every aspect. So I would say this sounds like how we took the Troy city from Troy city using the Trojan house, and we want to protect that. So once the person is inside that perimeter, there is absolutely no security. He's around. He's actually free to move around, and that happens. There have been a lot many use cases. There have been a lot of case studies around it that the perimeter was breached, and we've seen that you can actually have executables into your data files. And then once they're into that secure network, they can just spread around. That is how ransomware attacks happen. We got to secure it on that. So the thought was that why don't we segment them? But then again, we segment them and we create multiple parameters. And then we start about creating bridges between those parameters. So the problem is not fully solved yet. You know, we have mitigated it, but we haven't solved it. And that's what the zero trust security teaches us about. That it's not just about having those micro segmentations, having different parameterized components that we can build bridges with. Zero trust architecture says that everything in itself is a resource, and everything needs to be protected the same way. They need to establish a trust and then they talk to each other. In this debate between perimeter security and zero trust architecture, perimeter security has been working for us for quite a while now, and isn't that bad. It's just that that has to evolve into a zero trust architecture. It's the evolution. So that has served us quite well, and it still has its own benefits. But what zero trust architecture brings to it is that it says that everything is an independent resource, which basically means that it asks us to move away from that static network-based parameters, focus on users, assets, and resources, and that's what we do with our APIs. Isn't that what we're doing with our microservices? We have segmented them, and we put the custom defenses on top of them as they want it to be. So that's what zero trust architecture brings to us. That flexibility to bring custom made defenses. As for a network guy, it would say that you can allow that to bring your own device policies into it. You can have custom security for the resources. Same way as for API developers, we can say that we can have our custom defenses for different type of components. For example, my database, it would have a little different security than probably what my event grid would have. So, and it dynamically allows us to define those policy. It dynamically allows us to enforce those policy on the type of resources that we have. And that's what zero trust architecture brings to us. Moving on to the question that I get asked the most as a programmer, how do we do that? You know, I understand it's a great thing. It's bringing in the new technologies. It's bringing in the new defense. But how do we do that? And we're going to answer that question now. That we want to start with establishing the trust, a central uh, authority that basically tells you how that trust needs to propagate, how you need to set the policies, and there are different mechanisms of doing it. There are different protocols, there are different technologies how you want to implement them, but at the very basic core, we want to establish a trusted authority, a store where we can say that this is what the policies that we enforce on these type of resources. Now, depending upon your scale you have with your API ecosystem, the type of clients that you serve, the type of data that you have, your technical landscape, all of these things come into picture when you want to decide a way of doing that. And the best thing, you just need to stop at one. You can have multiple hybrid approach to your zero trust implementation, but still at the core, you want to establish a well-defined protocol that verifies every excessive voice. Now, the purpose of that protocol is not basically that you want to reject the things. It's that you want to assert that a genuine user is requesting via an authorized device and has the necessary rights to perform the configured actions on accessible data. So we covered every quadrant of the zero trust architecture. So you want to serve the requests which are valid in all of those four quadrants. And that's the purpose of it. And as I said, there is no one size fits all theory. You've got to look at your scale, your usage, your technical landscape, and bring in all the different topologies, make them work for you. Now we're gonna now we're gonna begin with the very first thing that I believe has already become the industry standard. As API developers, most of you must be using all of these things in your APIs, JWTs, open authentications, open identifications. But I just want to brush again on that concept a little and see how that actually fits in our ZTA architecture. And that I think is a very important technology. Now, we're going to talk about three ways of implementing ZTA. You can combine them to form your own hybrid topology, but all of them basically serves a little different purpose, and you can use them as per your purposes. So for APIs that need to connect a lot with end users, that has an identity management system. You must already be using JWTs, and you can leverage that to implement your own ZTA, the zero trust architecture. Now, a little refresher on it. What JSON Web Tokens are? They're basically JSON objects that has been signed, and they are stored with the clients itself, and you need to present that to the resource before presenting anything, and they have been signed, and they have a specified format, which is basically what we call the open authentication. It's again an RFC 6749 standard, and it's basically an open protocol. And when I say open, it's basically open because it's human readable. Although they are 64-bit encoded, you can just decode them. They're all human readable, and yet they are considered very secure because they use asymmetric keys. So you basically sign them using a private key, and anybody with a public key can basically go and see if you signed it or not. So it's more about that I've signed on your identity letter, and you present it to somebody, and that person can verify, it's signed by him, and then he can basically say, oh, now I trust you. So it's all about establishing that trust. And with open authentication, we use that protocol to basically formulate the JSON tokens, and it's basically the open identification part of it, the OIDCs, which basically tells us the identity of a user. So it's more about the identities provided by OpenID, and then OpenAuth, or what people call the OAuth. The OAuth then provides adds on top of it the claims that a person has on a particular resource, and we combine them and store them into a JWT, which is then presented to anybody else who's basically the resource that we want to commit to. So it's already evolved into a standard for the industry these days, basically, and we use asymmetric keys for it, and it's mostly useful when the API ecosystem intends to share data with unknown servers. So the real value that it drives out of is It allows unknowns, unrelated servers to basically trust each other. And and all of those are basically that trust that we provide is all per session basis. So which basically means, and in our case, the sessions is basically the web request. When you talk about the web APIs, it's basically the web request. So as the request comes in, we start a session, we validate the request. If it's valid, we provide the access to the data. And once the request ends, the session ends. Now, if you come in next time for a data request, well, I'm going to validate you once again. And in case of this JWT and OID, open authentication, if you look at it, where's the- so we've got an identity server, we've got an authorization server, and they've got pre-established trusts. So with pre-established trust, I basically mean that they have shared the keys. So for example, the OID server would have would have given the public key to the OpenAuth server, who can still verify that this server has basically signed that token. And then on top of it, it signs then the new JWT, which now also contains the authorization. And then again, that is a pre-established trust between all the components. Now, there's these components. Whenever a user or a particular process requests one of those components, it takes along the JWT. And since they also have the public keys, which basically means the pre-established trust, so they are basically able to validate the request. And on top of it, there's still some amount of SEM activities required, which we are going to talk a little later. But that's basically how you're almost implementing that the zero trust architecture within your own infrastructure. Now, another way of doing this is using managed identities. So managed identities is basically it's more about the enterprise level when your API ecosystem is basically serving the enterprise users. That's where it comes a lot of handies, and it uses an IAM systems. So IAMs is basically the identity and access management system. So I believe all of you must have been using Azure AD or some sort of Active Directory. They are IAM servers. They are IAM systems, and you can leverage that to bring your the ZPA from that enterprise ecosystem to your API ecosystem as well. And not many cloud providers such as Azure, AWS, the GCPs, they have their own IAM systems. And I'm going to talk a bit about the Azure because, as an example. So Azure uses the MSI, the Managed Service Identity Service, where it registers every component as an identity. You can provide your own identities or you can use a system identities, but it provides a single identity to one of every component. So that means that your Active Directory has everything registered. Your API ecosystem, the components to that API ecosystem is registered with an IAM system. Your users are registered with an IAM system. Your databases, your networks, your every single part is registered on that IAM system. And once you have those IDs, once you have that configurations, once you have the resistance, on top of that, you provide app paths. So these are basically role-based access controls, which basically means that you define some attributes for a particular registration to act on another registration. So remember, all of these registrations are basically components. So which can mean that your web application has a certain identity, on top of which you provide that has these actionable attributes on the database. That's basically managed identities for you. So what we have done is we're running out of time. We've got a short list.